Are you an injection mold toolmaker or an injection mold tool designer and you're using Fusion 360? Then we have a template for you. As you know, Fusion 360 does not have a template or an extension that you can use to create your standard tool bases. So every time when you start a new tool design, you have to recreate your own tool base. So here at BPNL Consulting, we had the same issue, and we've decided over the past few months that we are going to design a template that you can use. So we drive the template with parameters. You can put in any value, and it's linked with the 2D drawings. So how does it work? Let me go to Fusion and show you how it works. How does the toolbase work? First of all, when you download the file, you will download one native Fusion 360 file. When you upload it into your working directory, it will create two files for you. The one is the 3D model that looks like this. And the second one is the 2D drawing, looks like this. Now, there's all the dimensions in there. There's a bill of materials. And then for each and every component, we've created a separate page with all the dimensions linked in it already. So whenever you make a change in the parameters here, it will update everywhere here. The last two pages, very important. This is where you find the parameters. This is to show you what the parameters are. So there's your clamp plate thickness, A plate thickness, B plate. So there's the one page, and then the last page is more parameters. So everything that you see here, you can change it to whatever value you want. So where do we get those parameters? If you go to modify, change parameters, here we go. So in here, you will see there's your clamp plate thicknesses. Just to show you how it works, you click on that expression value, you put in a new value, and there it updates with the new value. There's your A plate thickness, that plate over there, A plate, sure you know which plate that is, 56 millimeters, and there it updates that for you. Just something, I'm going to change the B plate thickness, and I want you to notice how the pillars and bushes, the return pins, all that update as you make a change here. Let's make that 36, for instance. You'll see those lengths, everything update for you. So there's a whole bunch of formulas that was built in here to make your life a lot easier. So at a very, very small price, we ask that you would purchase this. If there's any problems that you come across, then please let us know, and we will be happy to fix it. Then a last few items I want to point out. If you go to sketch here, to the sketches, your part layout. What we've done here is I've put a sketch in here for you. The part layout is obviously the part that you want to place in your tool. I've created specifically here a 4-cavity. So the reason why I've created this sketch is so that you can easily, if you want to create a 4-cavity tool, you can just use that sketch and align or assemble with the joints your components to those 4 points. But obviously you can assemble it to the center point or wherever if you want to make, a single cavity tool. Then also, if you go to your ejector plate, let's get the ejector plate. If you go to the sketch, the ejector caps, we call it, that's where you can change and update the amount of ejector pins and where you want to place it. So what we do in here is we create a sketch with where we want the ejector pins, and then we assemble that to that specific sketch there. So I hope this is making sense to you. And yeah, I hope we can save you a whole bunch of time. It surely did save us a lot of time where we don't have to recreate all this every time that we start with a new tool. So yeah, enjoy.